System 1. The Recoil Pad. England's H.A. Silver Company patented the very first genuine recoil pad in 1874. A thin, hard rubber base vulcanized to a thick, solid rubber cushion the company called an anti-recoil heel plate, screwed directly onto the end of a shotgun's own wooden buttstock decades before any comparable product existed anywhere else in the world. That original Silver's pad arrived specifically to answer a genuine new problem created by the era's own advancing ammunition technology, since the modern shotgun shells that first appeared around 1860 let shooters fire dramatically more rounds in rapid succession than any earlier muzzle-loading design ever allowed. And all that additional shooting volume meant considerably more accumulated punishment landing directly on a shooter's own shoulder across an entire day spent afield or at the range. American trap shooter Frank Hawkins patented his own competing recoil pad design decades later in December 1919, driven specifically by the rise of lighter single-barrel trap guns that, while easier to carry and swing, delivered noticeably sharper felt recoil than their heavier double-barrel counterparts absorbed more naturally through raw mass alone during an entire competitive round. That specific innovation genuinely reflected a broader pattern within the sport shooting world, too. Since competitive trap shooters firing hundreds of rounds in a single tournament had every practical incentive to solve the exact recoil fatigue problem heavier, less portable. Double-barrel guns had never really needed to address in the first place. Poshmark entered that same market around 1930 and eventually became one of the most recognized recoil pad names in the entire industry. And modern versions have continued evolving well past that original solid rubber concept too, with companies like Kick-Ease building pads from sorbothane specifically because that material absorbs impact energy even more effectively than traditional vulcanized rubber ever managed. Custom gun makers still specifically offer premium leather-wrapped versions of that same basic rubber pad concept too, hand-fitting each individual pad flush against a stock's own dimensions before wrapping the entire assembly in genuine pig belly leather. A genuinely labor-intensive finishing touch reserved almost exclusively for fine English-style shotguns and rifles built to that same traditional standard well over a century after Silver's own original 1874 patent first introduced the underlying concept to the shooting world. System 2. The Mercury Recoil Reducer. A Mercury recoil reducer consists of a sealed metal tube partially filled with liquid mercury, inserted directly into a hollow cavity drilled into a rifle or shotgun's own buttstock, using that heavy liquid metal's own sloshing movement to absorb and redirect a portion of the felt recoil impulse an ordinary solid weight alone wouldn't manage quite as effectively. As the firearm recoils backward under normal firing, the mercury inside that sealed tube physically shifts and slides along its own length with a slight time delay compared to the surrounding rifle stock, and that specific lag between the gun's own sudden rearward movement and the mercury's own slower internal shift is exactly what spreads the sharp recoil impulse out into a noticeably softer, more gradual push against a shooter's shoulder. Competitive trap and skeet shooters specifically favor mercury reducers for that exact softening effect across an entire high-volume shooting session, since firing dozens or even hundreds of shells in one single sitting makes even a modest reduction in each individual shot's sharp recoil genuinely add up to meaningfully less fatigue by the very last round fired that same day, letting a competitor maintain considerably more consistent form and concentration through an entire tournament. Shooters and gunsmiths alike still genuinely debate exactly how much of a mercury reducer's real effectiveness comes from that specific sloshing liquid metal principle versus simply adding concentrated weight to the rear of the stock, since an equivalent solid lead slug of the exact same total weight would also measurably reduce felt recoil purely through added mass alone. That ongoing debate hasn't slowed sales of the genuine Mercury units one bit though, since manufacturers like C&H Research and XLR Industries continue selling them in multiple different weight configurations. Specifically because enough shooters swear by the noticeably softer felt recoil they report experiencing, regardless of exactly how much of that improvement traces back to the liquid metal itself versus the reducer's own simple added weight. System 3. The Recoil Lug. A recoil lug is a hardened steel projection extending downward from a rifle's own receiver, seated directly into a corresponding recess cut into the stock specifically to transfer the barrel and action's own rearward recoil force safely into the stock rather than letting that entire force concentrate purely on the action's mounting screws alone during every single shot fired throughout the rifle's entire service life. That specific load transfer matters enormously for both accuracy and long-term durability too, since a rifle relying purely on its action screws to absorb repeated recoil would gradually work those screws loose and eventually damage the surrounding wood or synthetic stock material through sheer accumulated mechanical stress across thousands of fired rounds. Gunsmiths specifically bed a rifle's recoil lug into its stock using a hardening epoxy compound during a process called glass bedding, creating a genuinely precise, perfectly fitted contact surface between metal and stock that eliminates even the smallest gap or inconsistency a rifle's own raw factory inletted wood might otherwise leave behind after leaving the original manufacturing facility. That specific bedding process typically involves a gunsmith mixing a two-part epoxy compound and carefully pouring it directly around the recoil lug itself while the action sits properly aligned in the stock, letting that same epoxy cure and harden into an exact custom-fitted mold unique to that one specific rifle. That precise bedding process directly affects a rifle's own practical accuracy too, since even a barely perceptible amount of movement or flex at the recoil lug's own contact point can meaningfully shift a bullet's actual point of impact between consecutive shots fired from the exact same rifle. Custom rifle builders specifically favor oversized or reinforced recoil lugs on genuinely hard-kicking Magnum rifles too, since the raw recoil force a heavy Magnum cartridge generates can gradually crush or deform an undersized lug's own bedding surface over years of repeated firing, a real long-term durability concern standard factory rifles built around more modest chambering simply never need to account for. If you've ever wondered how many parts work together to keep a rifle's kick from hurting the shooter, that's the kind of overlooked engineering this channel keeps digging into. Subscribe if you want the next one explained the same way. System 4. The Buffer Spring System. An AR-15 pattern rifle's buffer spring system consists of a weighted buffer riding inside a spring housed within the stock's own buffer tube, absorbing the bolt carrier group's own rearward energy after each shot before that same spring pushes the entire assembly back forward to strip and chamber a fresh round for the very next trigger pull. That entire cycling sequence happens in a genuine fraction of a second too, meaning the buffer spring system has to reliably absorb, redirect, and then return that same energy dozens or even hundreds of times in rapid succession without ever failing or noticeably degrading in performance across an entire high round count shooting session. Manufacturers build several genuinely different buffer weights for this exact same system, commonly designated by letters like H1, H2, and H3, each one adding progressively more internal weight specifically to fine-tune how the rifle cycles and how sharply the shooter actually feels that cycling motion transmitted directly into their own shoulder. Shooters running a suppressor or considerably shorter barrel than standard often specifically need a heavier buffer too, since both modifications genuinely increase the gas pressure and bolt velocity cycling the action. And an underweighted buffer in that exact situation can cause the bolt carrier to slam backward and forward with noticeably more force and felt recoil than a properly matched buffer weight would ever produce during normal semi-automatic cycling. That mismatch genuinely accelerates parts wear too, since a bolt carrier group repeatedly slamming into the rear of the buffer tube with excessive force gradually stresses and fatigues components never designed to absorb that same level of repeated mechanical shock over an extended service life. That same buffer spring system genuinely represents one of the most accessible, affordable recoil tuning components on the entire rifle platform too, since swapping a buffer weight typically costs shooters only a modest parts expense and requires no specialized gunsmithing tools whatsoever to actually install correctly. Competitive shooters specifically running the AR platform in fast-paced 3-gun matches often experiment with several different buffer weights before settling on their own personal favorite too, since the exact right buffer weight genuinely varies based on each individual rifle's own barrel length, gas system configuration, and the specific ammunition that shooter regularly runs through it across an entire competition season. System 5. The hydraulic recoil buffer. A hydraulic recoil buffer replaces a standard mechanical spring's simple compression with an internal chamber of pressurized oil, forcing that fluid through a genuinely narrow internal passage as the buffer compresses under recoil and using the fluid's own natural resistance to flowing through that tight restriction to absorb energy considerably more smoothly than a metal spring alone typically manages on its own throughout that entire compression and rebound cycle. Companies like Enidine originally developed this exact hydraulic damping principle for entirely different industrial applications, including shock absorption on heavy machinery and vehicle suspension systems, well before firearms manufacturers ever adapted that same core engineering concept specifically for taming a rifle's own recoil impulse, decades after the underlying technology had already proven itself reliable in those completely separate industrial settings. That fluid-based damping approach genuinely delivers a noticeably smoother, less abrupt recoil sensation compared to a standard spring and weight buffer too, since oil resists rapid compression in a fundamentally different, more gradual way than a metal spring's own comparatively sudden mechanical rebound. Precision rifle shooters specifically running heavier Magnum cartridges have increasingly adopted hydraulic buffer systems for exactly that smoother recoil impulse, valuing how a more gradual push against the shoulder genuinely helps a shooter keep their own sight picture and scope reticle on target through the entire recoil cycle rather than losing it to a sharper, more jarring mechanical snap. That maintained sight picture genuinely matters most for shooters trying to spot their own bullet impact or track a target's reaction through their scope immediately after firing too. A real practical advantage over a standard mechanical buffer that can momentarily throw a shooter's own view off target during that exact critical window right after the shot breaks. A window some hunters and competitive shooters alike specifically rely on to confirm a hit before deciding whether a follow-up shot is even necessary. System 6. The shock-absorbing stock. Italian manufacturer Benelli developed its own Comfortech shock-absorbing stock system specifically for high-volume shotgun shooters, building a series of chevron-shaped rubber inserts directly into the stock itself that compress and flex under recoil rather than transmitting that entire force as one single rigid, unyielding shock straight into the shooter's own shoulder and cheek, the way a genuinely traditional solid wood or synthetic stock inevitably would. That mechanical flex genuinely spreads the recoil impulse's own peak force out across a measurably longer span of time, too, working on the exact same basic physics principle every recoil softening system on this list ultimately relies on, cushioning a sudden violent force by letting it dissipate more gradually rather than absorbing it all in one single abrupt instant, transmitted straight into the shooter's own body. Competitive clay shooters and dedicated waterfowl hunters specifically favor this exact built-in stock flex for genuinely high-volume shooting days, since firing hundreds of shells during one single sustained hunt or competition round makes even a modest reduction in each individual shot's felt recoil add up to considerably less accumulated shoulder fatigue and bruising by the time that same long day actually wraps up. Benelli specifically marketed this exact Comfortech system as a genuine competitive advantage for exactly that reason too, arguing that a shooter genuinely less fatigued and less flinching by the end of a long shooting day maintains noticeably better form and accuracy across their own final rounds compared to a shooter absorbing every single shot's full unmitigated recoil directly into their own shoulder throughout that entire session. System 7. The adjustable gas block. An adjustable gas block lets a shooter manually fine-tune exactly how much propellant gas a gas-operated rifle actually taps from the barrel to cycle its own action, using a simple set screw or rotating dial to restrict that gas flow down to the genuine minimum amount the action actually needs to reliably cycle without any wasted excess energy driving unnecessary recoil into the shooter's shoulder every single time the rifle fires. Running a gas-operated rifle with more gas pressure diverted into the action than that system genuinely requires creates real unnecessary recoil and added wear too, since all that excess gas energy still has to go somewhere, typically manifesting as a noticeably sharper felt recoil impulse and considerably more wear, accumulating on the bolt carrier group and other action components over thousands of fired rounds across the rifle's entire service life. Precision shooters specifically use an adjustable gas block to dial a rifle's gas system down to the exact minimum reliable setting for their own specific ammunition and suppressor combination, since a suppressor attached to an unadjusted gas system typically forces considerably more gas back into the action than the same rifle would ever experience running unsuppressed, meaningfully increasing both felt recoil and overall mechanical stress on the entire action. That specific suppressor-related overgassing problem genuinely explains why serious suppressor owners consider an adjustable gas block practically mandatory equipment too, since running a fixed, non-adjustable gas system with a suppressor attached routinely produces noticeably harsher recoil and considerably faster wear than the exact same rifle experienced before that suppressor was ever installed on the exact same barrel and gas system configuration. System 8. The Recoil Reducer Insert. A recoil reducer insert, sometimes marketed under names like the Recoil system, uses an internal telescoping spring mechanism built directly into a rifle's own stock, letting the barreled action itself physically slide backward a short controlled distance under recoil before a heavy-duty spring smoothly decelerates and returns that same action back to its normal resting position ready for the very next shot. That telescoping slide genuinely represents a fundamentally different engineering approach from a simple added weight or a passive rubber pad too, since the entire barreled action itself becomes part of the actual recoil-absorbing mechanism, rather than staying rigidly fixed in place while some separate, purely passive component absorbs the shock on its own. Hunters specifically choosing a genuinely lightweight rifle for a demanding backcountry pack-in hunt often turn to this exact telescoping insert system too, since it delivers real, measurable recoil reduction without requiring the same significant added weight a Mercury reducer or a considerably heavier stock design would otherwise demand from a rifle already built as light as its owner can reasonably manage to carry across genuinely challenging mountain terrain. That specific weight advantage genuinely matters most on an extended multi-day hunting trip too, where every single additional ounce a hunter carries compounds across miles of difficult elevation gain, making a recoil solution that doesn't meaningfully add bulk or mass a genuinely valuable trade-off worth the system's own higher installation cost and mechanical complexity compared to simpler passive options like a standard rubber pad alone.